Hello viewers, welcome to our class today. Today we are going to be looking at logarithm in mathematics. A logarithm will have two classes of logarithm, and one of which is the natural logarithm, the one we use a table to determine, where we look up log of a number in base 10. In that logarithm, all the numbers are expressed in base 10, and so we use table to look it up, or probably calculator to solve. We use that. It enables us to simplify or solve a simple expression using log table. But this time around, we are going to look at theories of logarithm. What we call theories of logarithm. When you begin to express logarithm in other bases and begin to simplify logarithm in different bases, we generally refer to these as theories of logarithm. And when we do that, we do not require log table or calculator. There are simple ways that involves laws of logarithm that we can achieve this. So we define logarithm of a number, the logarithm of a number n to base m, to be that number to which the base will be raised to get the number. Let me repeat myself. The logarithm of a number n to base m is that number to which m will be raised to get n. So the logarithm of n to base m is equal to x if and only if m raised to power x is going to give us n. That is the simple definition of logarithm. Okay, if you go to that of natural logarithm, where we say that log 2 to base 10 is equal to, if you look up your table, you will get 0.3010. It simply means that if we raise 10 to the power of 0.3010, we are going to get a 2. That is what that means. And if you do this, if you punch this in calculator, definitely it will give you a 2. So that is logarithm, from which, if we understand this, then we know that this is the definition or the natural definition of logarithm. And from there, we can see just few examples before we go into the laws of logarithm. In this definition, it therefore means that if you have log 1000, for instance, base 10, it is going to be that number to which 10 will be raised to get 1000. How we do it is to say this is equal to a number which we do not know. The implication is that 10 raised to power a certain number will give us a 1000. And 10 raised to power 10 times 10, 10 into 3 places is definitely going to give us 1000. So 10 raised to power x is the same as 10 raised to power 3. It therefore implies that x is equal to 3. The same thing applies when we have something like log 4 or log 4 base 2. We say what number will you raise 2 to get 4? If we say it is equal to x, that means that 4 is equal to 2 raised to power x. Of course, that if we raise 2 to the power of 2, we are going to get 4, and that means that x is equal to 2. It is applicable in this type of logarithm. So this is the general definition of logarithm. A logarithm of a number n to base m is that power to which m will be raised to get n, and we can see that as a simple notation. So having known this, let us look at the laws of logarithm. The laws of logarithm. Number 1 we call addition law. Addition law. The addition law states that if a log of a number, say a to base x, is added to the log of another number b to the same base x, that we can put these two log logarithm, we can add them together by giving them the same log and then multiplying the numbers. That the log of a number to base x added to the log of another number to the same base can be gotten by just multiplying the numbers and putting them under one logarithm. That is the first law we call addition law. Okay, so this implies that if you have log 2 to base 10 plus log 3 to base 10, it is simply equal to log 2 times 3 to base 10. Of course, this is going to give us log 6 to base 10. That is the meaning of addition law in logarithm. The second is subtraction law. And in this law, it states that if log a to base x is such that log b to base x is subtracted from it, then if we are to put them together to have a common log, then it's going to be a divided by b. Because this plus turns to multiplication when they have a common log, the minus turns to division when they have a common log. That is the subtraction law. That's the subtraction law. And that means that if you have log, say, 100 base 5 minus log 4 base 5 is simply the same as log 100 divided by 4 base 5. And that is going to give us log 100 divided by 4 will give us 25 base 5. And of course, that we know that log 25 base 5 is that if we raise 5 to the power of 2, we get 25. So log 25 base 5 is simply 2. That is the subtraction law of logarithm. Another law we'll look at is the power law. The power law of logarithm. The power law states that log of a number x raised to power n to base e is equivalent to n log x base a. That is, if the log of a number raised to a certain power to a given base is to be expressed, the power is going to be a number brought behind the logarithm so that the power will multiply the logarithm of that number. Okay, so for example, if I have log 8, for instance, base 2, instead of looking for a number that I will raise to get 8, I can simply say that this is log 8 is 2 raised to power 3 base 2. And I will now bring forth these 3 so that we will have 3 log 2 base 2. And of course, the log of a number and its base, that is another law, is 1. So this is going to be 3 into 1, and that is equal to 3. Okay, as our answer. That is power law. The number 4 law is called power of the base. The number 4 law is called power of the base. Okay, when it is the base that has the power, instead of, in this case, that the number is having the power, then the reciprocal of the power is used to multiply the log. Don't confuse this. If it is the number that is raised to power n, then n will multiply the logarithm. But if it is the base that is raised to power n, then the reciprocal of n will be the one that will multiply the logarithm. As simple as that. Okay? So that if you have log, like we have here, 2 base 8 is the same as log 2 raised to power 3. You see that is the base that is carrying the power. And that becomes 1 over 3 log 2 base 2. And that is going to give us 1 over 3 because log 2 base 2 is 1. And you see that. Okay, that is power of the base, the number 4th law. Let's look at the 5th law. Logarithm to its own base. Remember, what is important in these laws is not the numbering, which one came first, which one came second. No, the arrangement is not necessary. The important thing is that you know the laws. This logarithm to its own base means that the log of a number to its own base, when the number and the base are the same, it's simply equal to 1. That is just the law. That means that if I say log 10 base 10, it is equal to 1. Because if we follow the law that a number it will raise to be x, 10 raised to power x is equal to 10. And then 10 raised to power anything that will give us the same 10 is simply 1. So x therefore is equal to 1. That is logarithm to its own base. Okay. The next is logarithm of 1. Logarithm of 1. It says that the log of 1 to any given base is equal to 0. How is that so? If I say log 1 base 10 is equal to x, you know that 10 will be raised to power x in order to get 1. And the law of indices says that if a number, any number raised to power 0 is equal to 1. So if we raise 10 to the power of 0, it should be equal to 1. And if that is the case, x is equal to 0. So the logarithm of 1 to any base at all is 0. And the logarithm of a number to its own base is equal to 1. I hope that is clear. Okay, the seventh law. The seventh law we call reciprocal law. It says that the log of x to base a is equal to 1 all over the base becomes the number and the number becomes the base. The log of a to base x. Okay, that is what we mean by reciprocal. Reciprocating. So if we want to get the log of say 1000 to base 10, we say it is equivalent to 1 all over the log of 10 to base 1000. Okay, let us see whether that is true. We know that log of 1000 to base 10 is going to be 3 because 10 raised to power 3 is 1000. Is equal to 1 all over log of 10 to base 1000. From what we said, if you have the log of 10 to base 10 raised to power 3, that this 3, because it is the base that is carrying the power in one of the laws, it will now be 1 over 3 log 10 base 10. This 3 becomes 1 over 3 because it's the base that's carrying the power. If it is the number carrying the power, it comes behind, and that's how we got this 3 here. So it means, and log 10 base 10 is 1, because log of a number to its own base is 1. So the answer is 1 over 3 here. So it means that this is 1 over 3. It means that this is 1 over 3. So the reciprocal of 1 over 3 is definitely 3. And you see that law is correct. Then finally, the number 8 law for now is what we call change of base. Change of base. If I set the log of x to base y is the same as the log of x to base a divided by log of y to base a. Okay, what it means that if I don't know the log of x to base y, but I know the log of x to base a and the log of y to base a, I can divide both together using the number and the base, finding their logarithm separately using a different base. Okay, what that means that if I am to get log 2 base 3, and I know what log 2 base 10 is and what log 3 base 10 is, I can simply say log 2 base 10 all over log 3 base 10, giving them a different base, and I will get that. So that is how it is done. So having seen all these laws, let us solve some basic examples. Okay, let's say we should simplify log 32 base 8. Solution: log 32 base 8, we say it is equal to x, that number to which 8 will be raised to get 32. And that means 8 raised to power x is equal to 32. And if you think, you will see that there is no number, no integer to which 8 will be raised to get 32, because 8 raised to power 2 is already 64. So it is good for us to reduce this 8. probably to 2. You know 8 is 2 raised to the power 3x. Then what will we raise 2 to get 30? If we raise 2 to the power of 5, it is going to give us 32. So it means that you can see now they have a common base. From a law of indices, we'll strike them off. So 3x is equal to 5. Therefore, we divide both sides by 3 so that x is equal to 5 over 3. X is equal to 5 over 3. That means that log 32 base 8 is 5 over 3. So 8 raised to the power 5 over 3 will definitely give us 32. So that is how this becomes the answer to this question. Let's solve one more example. If we have to evaluate log 0.25 base 8, okay, this one looks a bit scary. Log 0.25 base 8 is equal to, first of all, I will advise to change this to fraction. 0.25 is 1 over 4 base 8. When you change it to fraction, this fraction can as well be changed to index, and that is equal to log 4 raised to the power minus 1 base 8. And from our law of logarithm, this power can come behind, so that it becomes minus 1 log 4 base 8. Okay? And we know that this can as well be written as minus 1 log 2 raised to the power 2 base 8. I'm using this method, and this 2 will also be brought forward, so that we'll have minus 1 times 2 log 2 base 8. And that will give us minus 2 log 2 base 8. And we also know that 8 is 2 raised to the power 3. And there is a law that says that if the base is carrying the power, then the reciprocal of that power will be used to multiply the number. So we already have minus 2 here. Then this one will be written as 1 over 3 log 2 base 2. And we know that the log of a number to its base is 1. That is going to give us minus 2 times 1 over 3, and that is minus 2 over 3. So it means that the log of 0.25 base 8 is equal to minus 2 over 3. As simple as it is. For example, and we'll go for today, example 3. If we are asked to evaluate log 125 over log 5. Now, this is a logarithm that we do not know its base. But we know that when you have this, that there is a law that says that if the log of a number to a certain base, you can use the log of that number to be divided by the log of the base, giving them a different base. So we can rewrite this log 125 over log 5 to be equal to whatever the base is still equal to log 125 base 5. This becomes the base. There is a law like that. So that means that log 125 base 5 is equal to, of course, is log 5. 125 is 5 raised to the power 3, then base 5. And because this power is for the number, you bring it behind, so that it becomes 3 log 5 base 5. And log 5 base 5 is simply 1. So you have 3 times 1, that is equal to 3. And this implies that log 125 over log 5, whatever the base may be, is equal to 3. That is it. See you in our next class.